Hi, everyone. So it's great to have a talk on a Broadway. So it's my first time on Broadway, and now I have a talk here. So my name is Sajjad Farahani. I'm a lead data scientist at Credit Analytics New Product Development at S&P Global Market Intelligence. So I want to talk about the application of machine learning for spreading financial statement. I will going to discuss a little bit about the framework to assess different machine learning algorithms and the trade-off between different approaches. And then I'll go over a framework and just a case study, a pro-spread, a solution that the team has developed. And then I'll conclude and leave it to some questions. So just a quick outline. I'll discuss a little bit about the S&P Global, what it is, what it's doing, and then I'll go to discussing some techniques in machine learning, in risk, the trade-offs that we always have between the variance and bias, and then I'll go to the case study of document-based financial statement assignment, and then I'll conclude. So S&P Global Standard & Poor has different major business lines. S&P Global Rating, which effectively rates public entities. The global indices like Dow Jones, S&P 500, S&P Global Market Intelligence, which is the team I belong. It's a data analytics provider, helping different clients mainly focus on toward the risk management. And then the S&P Plat or Commodity Insight, which is have a source of information about the commodities and energies. And within the S&P Global Market Intelligence, our team is mainly focused on a variety of different risks, credit, market, and operational risk. So the team tries to leverage a lot of techniques in machine learning, a lot of unstructured data to help our clients to make a better decision and manage their risk. So as a data scientist, we always kind of have to answer a different set of questions, like going back to our stakeholder and see they kind of reach out to us with a variety of different questions, but they won't know exactly what type of techniques we have to use or how we have to approach those problems. So we have to make sure we don't end up over-engineering tools, building a complex model or product that it's really hard, if not impossible, to maintain. And it's also, we have to make sure that the product or the model, we can scale it for other use cases at some point. So generally speaking, like we all know that we have to go through different steps when we want to build a model. So we have to do the data preparation at the beginning. So I'm doing some initial pre-processing, cleaning the data, doing some data transformation, some label texting, like if, for example, we want to do some sort of sentiment analysis. And when it comes to then, the next step would be the model definition. We have to define a set of targets and features, define the methodology. We want to see like what are the models that we want to build, make sure the data is ready. Like, for example, we want to use like random forest, lasso, neural network, and then again going back obviously to training and all different type of models, and then do the testing. Looking at the overall result, like I don't know, like for example, we look at the recall, the general ROC, see how each of these models are performing, pick the right one for our business, for the problem that we have, and then obviously we go to the next step, which is implementing and deploying it for the production. And then we probably have to have a benchmark. So we want to like, okay, we have the model, it's running, we are using it, but we have to always have a benchmark to test it against another model and see if the performance is iterating, or we want to just like retrain or tweak it a little bit down the road. So the trade-off, so it's a key component for us. Like, for example, we're having different techniques. Like, it's always going back to like, so what's the best model I can pick? Like, we have the low bias and high variance models, and the other side we can pick which are like very complicated models. And other side we have the high bias but low variance model. So like we can just, for example, seeing on the left, we can pick a model very structural form like a quadratic regression, which is represented with the line. It's simple enough, but probably not very good in understanding the pattern of the data and following that. But then we can just go with a random forest, high variance in this case, but the model, maybe here we can just face the overfitting. So then it goes back to the trade-off. Like if you want to have a very simple model or very high and complex or complicated model. So that goes back to here, that we want to just find the sweet spot to minimize the total error. Like, for example, you see, like in this case, the nonlinear regression, even it's not similar as the random forest or the quadratic regression, but quite a bit it's good in following the pattern that we see in the data, and that's probably the way we should go for in this case. So again, if we go to this white paper, you can read more about the S&P Global perspective on machine learning and credit risk. The problem, like we always face when we go to the clients, is like trying to explain to them the complexity of the models versus the other models that we could have built, like algorithms that are much simpler. So this table is a good example showing the level of supervision and the complexity of different techniques that can be used when we build different models. So that's actually a very good example when we show it to our business stakeholders. Like going to some sort of traditional techniques like logistic regression or general linear, they are very tightly coupled to the data sensitive to outlier transformation. They require actually a lot of transmutation. So that means the supervision level is much high. But at the same time, the complexity of the model is low. So it's very easy to explain. The end user will understand it easily, how the model is performing. So a lot of cases, we have to use a simple model, like because of, for example, the regulation, we cannot go with something out of the box, like, for example, the last example, gradient boosting. And then we can go to comparing it with the random forest. Random forest is very typical, commonly used machine learning algorithm. It can deal with a lot of the noisy and polluted data, harder compared to the traditional ones to explain, but the accuracy can be equivalent when the data is well structured. So, but in this case, the level of supervision is lower, so probably it's easier to build this type of models, but complexity is higher, but it's still lower than the last one, which is the gradient boosting. Much more difficult to explain. So there are a lot of other ways now we can try to explain this type of like gradient boosting, but it's still, if you want to just do a comparison between these two, gradient boosting is much harder. But again, this level of supervision here, if you want to compare these two, is lower. So just to have an idea here, like it's not necessarily mean that we have to pick the most complicated algorithm and technique to use. Sometimes a simple algorithm and model can be as helpful as the other ones. So now I just want to go to our case study. So that's the solution or problem actually we had at the beginning. We wanted to try to help some of our clients. So a lot of non-corporate financial and banks have exposure to small and medium-sized companies because of the way they're doing business, the supply chain and lending activities. And the main goal for them is to being able to manage the risk. The way they do the business is they're asking those customers to submit the financial statement, and then they go through that financial statement, they extract the information as they need, they run some sort of analysis, scoring models, and they understand the financial condition and health of those customers, and basically they decide, for example, if they want to give them any loan or not, or approve the loan application, so, or if they want to do any business with them. So here that comes, the process is very manual. So these financial statements are not something like public that you can go online and pull them from out of the internet. These are small private companies. They are proprietary. They're given to our clients only and for the purpose of checking their financial health. So the process, as you can see, it's pretty much manual. The financial analyst has to go through these financial documents, try to enter line by line the information from these statements into some sort of a spreadsheet, and so there can be a lot of mistakes may happen, and then running some analysis, and then, for example, running some models against it. So highly human dependent. And they use Excel, for example, which, as we know, it's hard to store and reproduce and reuse it like later on down the road for another customer, so they have to kind of repeat the same process again and again. So that comes when, for us, we wanted to automate it to this process. So when they get the financial statement, we can just extract the information and then map it to our dictionary and like the equivalent mnemonics that we have, the chart of accounts, and that's how they can run the suite of different models that S&P has developed to understand the financial health of those companies. So this technique called spreading financial statements, it's defined as a process by which a bank transfers information from the borrower's financial statement into the bank's financial analysis spreadsheet program. When the financial information is, if the financial is inputted correctly, this spreadsheet can generate meaningful financial reports to assist the bank in its analysis if the financial condition of the company is correct. So again, these are like coming in cash flow statement. So we have to kind of pick the right line, match it with our dictionary, and that's how they can use it. Going back to this type of the data that our clients are getting, these documents are pretty much noisy. They don't have a standardized format because, like, for example, if you go to the financial statement of public companies, they are pretty much standardized. Like if you go, for example, like look up for financial statement of, say, S&P, year by year, that they use basically the similar template. They don't change much, but that's not the case for smaller or private companies. They come in different formats. Sometimes they submit a statement in PDF. It could be an image. The quality is also different. Based on their exposure, like if they're working with the customers or clients across the globe, so they may come in different languages, so that's another issue. And then they get a lot of those documents because of processing a lot of those, so the volume is pretty large. And then the most important thing is those are documents for private companies, so they're giving it to them by having that expectation in mind that they are secured and in the right hand. So now that's the time that we have to start thinking. We got some unstructured data, variety of format, quality sometimes pretty low, and we want to get something like that, very clean, structured data, and then we can run some of our credit analytics model against them. So now it's when it comes to us, to the analyst, data scientists, like how I can solve this problem. So if you look at just having that's a pipeline overview, we have to, question probably now can be answered like by a very simple, like on a higher level, we can say, okay, I want to run some optimal character recognition in image enhancement, and then I want to get something more structured, list of, then I do the table detection, then I'll have structured output with some metadata, and then I'll send it back to this and like process assignment engine. So I'll run through different algorithms to map those to the right mnemonics that we have. So because we are using, we're having different languages, like multiple languages, say like all these Latin-based languages, we have like English, Dutch, German. The taxonomy is relatively limited, so that's the way to go. And we want to just go and map each financial statement line of item to our dictionary, which we have a mnemonic associated with it. So after that, we also, because we are using a fuzzy matching approach, we allow the user to just go through all this assigned, whatever values was assigned, and by just doing a thumbs up, thumbs down, just verify or decline what we assigned. And that goes back to our online learning. We will use it, we update that dictionary, so we have a specific dictionary now built for this individual, or this company, which won't be shared with other companies at the end. It will be solely used again by the same company. So the next time when they have another financial statement similar to that, they don't need to redo it again. So, and then from here, the business more or less would be as usual. We'll, using our technology, to just send whatever we got here back to different suite of different credit analytics models, which will be used to score. Like, for example, we want to get the probability of default for that customer, and that would be the output here. So that's another overview of this solution, ProSpread. So we have this data, and that's the output. But this is what the user also sees. That's all the data that was structured here with all the mnemonics that we were able to match. And then I'll talk about this deficit and overage in a little bit. Again, the user can also give us their feedback. If they find the matching is not right, they can tell, like, basically give us the feedback by accepting or declining that. And then at the end, that's one is of the output that they can get, which is the company that's been scored using maybe some of other data provided by S&P and the models that we have developed. So this is workflows of the prospect. So this solution prospects coming in different versions, like you can use the desktop web service or even the local install. And as I said, we have to go through this table extraction and spreading. We have different ways to assign these values using different engines, balancing and assignment. And then they both using our global, which is what we define, like the dictionary, and then the company level dictionary, which is based on what also we've learned from the company's feedback. And then we have different set of outputs that can be used, like if they just want to get their Excel as an output of what we extracted from the financial statement, or it could be also the score that they got from our models. So going back to this, so we got the files, we converted them to some sort of images. We do just a quick table detection because all these informations are sitting in those tables. We don't need to worry about other text in a financial statement. The values are in those tables. But like, for example, if you got a large document, we don't want to just go over all of these documents. We want to just pick the one that they have some tables in it. And then we do the image processing, OCR, and then we identifying the exact tables, we parse the information, and now we have the data. So then, like what example, we use this dictionary-based approach to assign the values, semantically matching them to our taxonomy. Like we can just get exactly the right mnemonics for it. And then another way is using the balancing engine, which is constructing accounting graph. We track the deficit and overage. We also show it to the users so they can basically see if there is any mismatch. So that's a way to improve our assignment. Oh, I'm sorry. So I don't have the timing, so I hope I'm okay. That's the architecture of this machine learning architecture of this prospect. We have these documents coming in variety of different languages and formatted. They have to go through extraction. So we do the conversion, do the optimal character recognition. We do at the end, we go take it back to table detection. And now we have the data ready, sending it to different engines, balancing and accounting. So once we have that, so from here, the process would be similar for any other stuff that we have. Like we send it back to our scoring engine, which running those scoring models against them. That would be the output. But at the same time, we also look at the user's feedback. So if we require sending, like we have this online learning, so whatever we are getting back from our clients, from the users, so it may really require some reclassification based on what we've learned from the user. And then here it's simple. We expose it a JSON Ajax to the UI, and we have also the Excel plugin. That's when it comes to, for the user, if they want to just change the inputs or tweak the model inputs and see how it works. So that's pretty much an architecture, like on one of the views. So if I go a little bit higher, so we have this UI. That's when the users are coming in to upload the documents, and these are so many images we'll be uploading, and then we have to kind of use S3 to store them. And so for this, all of this processing, after we check them out, we just get rid of all those images, and then there are some API calls to any of these dockers. So if you want to doing one of each of these steps, That's how it works. So we're getting a lot of post requests, and so that's another way of high-level pipeline. It's a highly elastic computing, so we have to kind of do load balancing because we're receiving a lot of documents. Majority of them are pretty small, but some of these documents are coming in like 200 pages. So we don't want to just have other users waiting for that one be processed. So we're also using the Kubernetes for containerizing this, and the way we do this, so right now we have a queuing which is the first in, first out, but we have to kind of also adjust it based on the size of the document. So we have some sort of algorithm that decides like if they have to go through a different route. Like if now we have a 200 pages documents that there are tables in most of them, based on that we just pick another route for that to make sure that user won't wait much longer. And this is the output of, we use the UI that we have. So here we use the Shiny app. It can be done in using Python dash with using some other packages. But here we just use the R Connect to deploy it for testing. So that's not the production. It was just a use case to show it to the clients and going through the user testing, making sure the workflow end-to-end is working fine. And after that, when we made sure everything is running as we expected, then we went for the production and basically ship this to the production. So here you can just basically go and try the per spread by yourself, like uploading any financial statement that you can probably find somewhere as an example, and try it and see how it works. Here, list of my colleagues who actually worked on this product too, and we always using the latest technology here and S&P Global to make sure we can solve the complex problems that our clients are facing, and we are there to respond to their needs. I'll be happy to answer any questions. Thank you.